Good afternoon from Lisbon. I must say today that the meteorological spring is coming, and this is the last week of meteorological winter. Nevertheless, it seems that the wintry weather continues to affect European countries. So over the Atlantic and Europe, in the upper levels, there are some troughs which we have to pay attention today. There is one over Azores, another one over British Isles, and another one over Western and Central Mediterranean. Further east, there is a high pressure system with some stable conditions, and we also have over Iberia some high pressure reach also over Iberia. So here in yellow, we have the winds at 300 hectopascal from the model, and it can tell us more or less where the jet stream approximately is, but also the water vapor image, water vapor information can give us that information where is the jet stream. So we can check near the dry areas or the darker zones. Usually the jet stream is nearby. But also keep in mind that these darker zones can also mean dry descending stratospheric air and ongoing cyclogenesis. And the moisture and also the boundaries between moisture and dry areas, that also can be areas of convection initiation, for example. So these dry, darker zones in the water vapor 6.2, it's important also because it can be also areas of severe weather. Also, the Airmass RGBs also an helpful information because it can give information what type of air masses are present, and also some hints of the dynamic processes in the atmosphere. So today, at 6 UTC, at least, the warm air mass is pushing to the south. We can see some green areas over Iberia and north of Greece, which is in this case is consistent with a southerly flow from both the low from the west and the high pressure system further east that almost we cannot see in the image. The bluish colors are dominating most of the area. So in this case, it's cold polar air mass. With the mean sea level pressure, we can identify the low pressure system associated to the troughs I mentioned before. There is one north of Azores, which is moving southeast and will affect Iberia tomorrow. Another one over British Isles, which is also moving east and southeast. And the other one over southeast France. And all of these three low pressure system have a frontal cloudiness, and also there is another one I forgot. There is another one more or less in Germany, and also has some frontal systems. And we can see in all of the low pressure systems, the first three I mentioned, some reddish colors, and this it indicates dry air masses in this RGB, but it can also indicate some areas of subsiding air, PV anomalies, and of course the position of jet streams. So this RGB gives a lot of information of the dynamic processes in the atmosphere. Behind the frontal cloudiness over British Isles, it's possible to see some large area of convective cells over the sea and in the cold air behind the front. So these are some open cells and some closed cells. And approaching Ireland, we can have maybe an enhanced cumulus area. So in the next hours, some frequent showers and possible thundery showers and heavy showers. You can see also in the area of south of France. The ridge over Iberia and the low further east is increasing the gradient, and strong winds are expected in this region. Of course, air mass and water vapor don't give information about what is happening at surface. So let's see these two RGBs that can help us with that. Night microphysics on the left and natural color RGB on the right. On the left side, so we can see some frontal thick cloudiness. They are showing in red. And further south near Madeira, for example, we can see some darker bluish colors indicate the thin high-level clouds. If you remember, in this area were more or less the position of the jet stream also. Over France, we have some low-level clouds, and so it's possible to see some fog or low-level clouds. They appear in this RGB in pastel colors, and they can be more greenish in case of small droplets are present. On the right side, with the natural color RGB, we can see some hints of this bluish cyan color over Italy and further north, associated with the frontal cloudiness. So this cyan color indicates the presence of ice crystals on the cloud top. So this can be also high-reaching cold clouds, like frontal clouds, but also it can mean thin cirrus. So this cyan color. Further east, there is also some large areas of this cyan color, so means ice crystals. In this case, it's snow on the ground. And the whitish color, it is, we have some thick water clouds. So we have here some mixture of free cloud areas, and we can see the snow on the ground, but we also have some thick water clouds that are whitish. And of course, we have further west in this natural color RGB image, we have the frontal cloudiness with some ice crystals on the top. Okay, so these are the observations at 6 UTC, and we can see here some large areas with fog. So the fog information is the yellow stripe symbol, mainly in the eastern part of Europe, and also some green dots, which indicates the rain. And there is an observation in Italy. I'm not sure if you can see this one here. I'm showing with the mouse, and this observation indicates thunderstorm in the past weather. So this low pressure system will bring some severe weather in this area in the next hours. There is also some weather warnings from this area for thunderstorm, rain, and wind. And over UK, you can see some this radar data showing more or less the position of the front, and of course there is a 4 dots over here, the green dots showing that it's heavy rain at this moment at 6 UTC. Okay, so we were talking about the snow on the ground, and the cold air has been affecting large areas of East and Southeast Europe and parts of Middle East as well. There have been several snow events as the low pressure system was dominating this region. Not anymore, because now we have a high pressure system and with cloud-free areas, and we can see the snow on the ground. We have already seen it with the natural color RGB, and now we have the opportunity with this new cloud phase RGB from MTG. So this image is from yesterday at 12 UTC, and the cloud-free free areas show snow on the ground. This is the snow on the ground appears in this RGB dark medium blue, and the main contribution is from the 0.6 channel, which is in the blue beam. You can see the recipe on the top right corner, and here the snow reflectance is high in this channel, so in this visible region of the spectrum, but it's really the reflectance of the snow. It's much lower above the 1.4 micron. So it's the main contribution of the visible 0.6. Keep in mind that the appearance of snow also depends on the snow characteristics, but it's a nice picture from yesterday, I have to say. Of course, there is another one from yesterday with a very interesting system over France. It's this RGB it's really good for the separation of water cloud, to show the separation from water clouds that are pinkish and the ice clouds that are blue. But it also gives us a good color contrast between small and large particles in the case of thick clouds, so both thick ice and water clouds. So this RGB provides good cloud top phase identification for thick clouds. Well, as I mentioned before, the position of an high pressure ridge over Iberia and the low pressure system to the east is originating strong northerly winds over south of France and over the sea. So these are local winds. They are known by Mistral and Tramontane. I'm not sure if I'm saying well. And these winds are going to, in the next hour, there will be an increase in the significant wave height over this area of the Mediterranean. And we can see here with the information of the ECMW model. But also last night, we can already see these very strong winds, northerly winds over the area. We can have here some information, some data of 7 in Beaufort scale, so approximately 30 knots. Also, near African coasts, it's possible to see some changing in the wind direction, and that can be the position of the cold front at surface at that time. So you can continue to monitor this evolution, the evolution of these situations, strong winds increasing in significant wave heights with wind data from scatterometer sensors and also the significant wave height from altimeter data. Okay, that's all from my side, the situation at today. And thank you.
I'm Bruno. I'm Bruno Café. I'm Ângela's colleague at IPMA, and we are going to look a little bit for past events for these last month. So we start here first with some data from Storm Eowyn. So Storm Eowyn was attributed by the Western, her name was attributed by the Western Storm Naming Group, and this group is constituted by the UK, Ireland, and Netherlands meteorological offices. The storm had a very rapid deepening known as explosive cyclogenesis. The mean sea level pressure went from 1991 hectopascal at CUTC on the 23rd of January to 9041 hectopascal 24 hours later. So it greatly exceeded the 24 hectopascal in 24 hours limit, above which cyclogenesis is defined as explosive at 60 north latitude. And a wind red warning was issued for the British Islands, namely for Ireland and Northern Ireland. So here you can see the ECMW forecast portraying the pressure drop of the low and its fast movement towards the British Islands. And the British Islands are highlighted with the red circle for better reference. There was a strong jet stream present, as you can see on the top left image, which has the ECMWF forecast for wind at 300 hectopascal on the 23rd at 0 UTC. And it was the interaction of the low with this jet that allowed for the very rapid deepening. We have the Airmass RGB here on the right, and this RGB, as Ângela showed, is composed by a red beam with two water vapor channels, the 6.2 and the 7.2 and the 7.3, and their difference helps to understand the vertical distribution of humidity. So low values means that there is mid-layer humidity and mid-level clouds, and high values are for dry upper layers or high-level clouds. The green beam has two infrared channels, 9.7 and 10.8, and their difference helps to identify clouds on various levels and the height of the tropopause, mainly because it's ozone sensitivity. And low values relate on the green beam, relate to the ozone-rich troposphere, so colder air masses, as high values correspond to ozone-poor troposphere, so warm air masses. Finally, the blue beam with only the water vapor 6.2 inverted, so low values are for dry upper layer and high values for moist upper layer. The Airmass RGB can be used to determine the location of a subsidence zone, namely the descending of dry stratospheric air near the storm. And in the RGB table on the top right corner, it's represented the RGB air mass corresponded to the darker area we see pointed by the yellow arrow on the RGB air mass. And just where the subsidence is starting to occur. We can see that we have relatively low values for all beams in this table, representing a troposphere with dry upper levels and ozone-rich with some mid-layer humidity, and is consistent with the start of subsidence near the storm. So 6 hours later, these images were retrieved, and now the deepening becomes very obvious with the low values for the green and blue beams representing the ozone-rich troposphere and with dry upper layer, synonymous of tropospheric intrusion. So the storm had a very rapid deepening in these 6 hours, and that continued in the hours after as the storm headed fast in the direction of the British Islands. If you look at 10.8, that is sensitive to surface and cloud top temperatures, and that is a 10.8 inverted image we can see here. And the warm temperatures provide a low contribution. So low clouds, surface land or sea surface with a low contribution, and the cold temperatures provide high contribution. So they showcase the high clouds. The water vapor 6.2 is sensitive to water vapor at around 300 hectopascal geopotential. So low humidity at that height has low value, dark, and high humidity as high value, white. And in this image of the 6.2, it's visible the dark area where subsidence is occurring. The next images show a potential jet, the steam jet forming in the dry intrusion zone. So the 10.8 and 6.2 channels are showing a characteristic dark zone consistent with sinking air and also clouds that form the typical sting usually seen on these images as the cloud starts to narrow and descend, evaporating and cooling the air and generating a maximum wind speed at low levels with potential high damaging winds reaching the surface. You can search for a conceptual model in our EUMeTrain site for the steam jet. So on this day, the highest gust registered in the weather stations of the British Islands was 183 kilometers per hour in Maystead, Ireland, with a sustained wind of 137 kilometers per hour. And here you can see 4 images from the 10.8 channel acquired at 2, 3, 4, and 5 UTC. And now for a little bit of interaction, can you say at what hour do you think was registered the maximum gust at Mayset according to the satellite images? Yes, okay. So this is the sting. So the gust was registered at around 5 UTC, and it is consistent with the approaching of the cloud-shaped sting to the western shore of Ireland, namely Mayset, which is here on this part of Ireland. So looking at some scatterometer data, which give us the intensity of the wind over the water. ASCAP-B scatterometer passed over the storm at around 22 UTC on the 23rd and detected winds stronger than 50 knots, with the highest winds registered to the south or southwest of the center of the low, on the area where the jet was starting to form, as you can see on the 10.8 image for around the same time. And here you can see the area with winds higher than 50 knots. Here you can see other data from the ASCAP-B before and after the Mayset gust, and ASCAP-B had passed over or near the center of the storm, and also with high wind values over water. Here you can see several passages from the altimeters above the area, which give us an approximate value for significant wave height, and they are compiled on the left by a 0 to 12 UTC, and on the right for compiled with a 12 to 24 UTC passages on the 24th of January. So regarding this altimeter data, it was also retrieved high values, wave values associated to the wind generated by the storm, with waves around 9 to 11 meters on the marked red circles. Another storm that hit this western part of Europe was Storm Herminia. So it was a few days later, and its name was attributed by EUMeT from Spain, which is one of the countries represented in the Southwestern Storm Naming Group, along with Portugal, France, Belgium, and Luxembourg meteorological offices. One of the important warnings issued was a red warning for significant wave height for the northern and western coast of the Iberian Peninsula. You can see here marked with a red circle for a better reference, the Iberian Peninsula. Comparing it with the storm Eowyn, its approach to the British Islands was much slower, although it also had an explosive cycle genesis in the prior days, reaching 954 hectopascal of mean sea level pressure on the 26th at 12 UTC. But here you can see that the movement forecasted in 24 hours between 26 at 0 UTC and 27 at 0 UTC, that this movement or the path was much shorter than the one described by Storm Eowyn in the same length of time as it approached the British Islands. 12 hours after that, the low was still located west from Ireland. So here you can see a different pattern in the satellite images, and the ones observed for the same RGB and channels in Storm Eowyn. Let's try again. See if you can point for where the jet stream is located on these images. The jet stream region is very well defined in these images. Airmass RGB and water vapor 6.2. Yes, so yeah, pretty good. It's a very highly contrasted region. You can see it very well. Yes, also up there. But okay, so going for next slide. So there was a strong jet stream, as you saw, and it was much more to the south of the low than the Eowyn storm case for the same region. And you can see on the top left image, which has the ECMW forecast for wind at 300 hectopascal on the 27th at 12 UTC. And also Storm Herminia located more to the north, near Ireland in the 10.8 channel. Looking also to some scatter meter data for this event, we had 2 passages on the 26th, west from Ireland, with winds above 50 knots, and 2 other on the 27th, near the Gulf of Biscay, which is north from the Iberian Peninsula, with winds above 40 knots. For the altimeter data for this case, on the left, we have also the accumulation for the period between 0 and 12 UTC. On the right, for the period between 12 and 24 UTC. This for the 27th. And the particularly slow movement of the storm Herminia, along with the intense winds generated by it, created a very large and stable fetch area. And so it was possible to observe values of significant wave height retrieved by the altimeters with 10 to 12 meters in a large part of the observation lines, as you can see. The highest values for significant wave height observed by the buoys of the western coast of Portugal are on this table here on the right, and you can see that there is like 10 meters observed on the northern buoy, more to the north of the western coast of Portugal, and 7 meters more to the south, and with the maximum height waves of 16 and 8 meters respectively. And just for reference, the red warning for the western coast of Portugal for significant wave height is for waves above 7 meters. And here you can see the validation of the ECMWF forecasted significant wave height with the retrieved data from 2 altimeters. On the left, there is a forecast for the ECMWF predicting 10 to 12 meters of significant wave height to the north and the west coast of the Iberian Peninsula. And this is superimposed with a passage of the respective altimeter, and on the center we have that isolated path of the altimeter for the same periods, and on the right we have the comparison between the observation and the forecasted values, and there is a good correlation with waves reaching values as high as 12 meters. So this was it. I'll just end with the high resolution visible RGB from the 14th of February at 10 UTC, where you can see some low clouds over the Tagus River. It's the river that passes south side of Lisbon, and a picture taken at the same time from one of the 7 Lisbon hills, showing a fog event that occurred several times during this February. Thank you very much.